Happy day. Let's continue the class. In that one, I was saying you that the maximum path difference between the two waves meeting at any point or interfering at any point is equal to the minimum distance between the two sources. So you can see in this particular case, what is the minimum distance between two sources? It's 2 meters. Okay, so where can they meet? The meeting point can be in the line, either in this way here, which is joining the two sources, or it can be at this point. Okay, suppose at this point we say that this point is Z and this point is, let's say, T. So you can see that S2T minus S1T will be what? S2T is this distance and S1T is this distance. What is the difference? This much, that's 2 meters. And same way here also, you can say S1Z minus S2Z, that will be 2 meters. So that is the maximum path difference between the waves generated by S1 and S2. Now, if this is the maximum path difference for maximum intensity, and this we are going to write as n lambda. Now that means lambda being a fixed quantity. Okay, then that means this n is the maximum because lambda is fixed quantity. Are you able to understand? Is lambda fixed? Yes, lambda is half meter for this particular question. You can't change it. Okay, so if this is maximum, lambda is fixed, that means this n is the maximum. So how much is maximum? Let's see. This is 2, lambda is 1 by 2. So that means 4. That means how many maximums are possible? 4 maximums are possible. Here is 0. After that somewhere 1, 2, maybe somewhere here 3rd, and here is 4. So how many? 1, 2, 3, 4. Same way, is it possible below also? Yes. So here also 1, 2, 3, 4. The total 4 plus 4, 8 plus this 0. That means 9. So total number of maximum intensities possible are 2n plus 1. What is n over here? This is n. So 2 into 4 plus 1. Okay. Let us solve another question. If we solve this one, all the interference problems we must have solved, and then we will start standing waves for longitudinal waves. Okay. So this is the question here. In this one, here is a source. Source is producing the wave. That wave, one of the wave is going, getting reflected and coming back over here. And one direct wave is going like this at point D and producing interference. This is the reflected layer. Reflection layer. Okay, this is the source. This is the detector. One wave is going like this, getting reflected from here and coming back, and one is going direct like this. Both are interfering here. Okay, and producing the maximum intensity. They are in same phase. They are producing maximum intensity over here. Okay, and this you can say is H, and this we can take as D. Okay, then the question says, if the reflected layer is taken slightly above to height H, in that case, at point D, no signals are detected, no intensity is detected. Okay, then find the relation between D, H, small h and the lambda. Lambda is the wavelength of the wave produced by the source. Okay, two cases are there. One, when the reflected layer is at height capital H, then we are getting here maximum intensity. When the reflected layer is taken height H up, in that case, reflected layer from here and the direct one, they are out of phase. No intensity is detected at D. Okay, both the things we have to write. First, let's write for this case, first case. Okay, in that case, I am calculating delta x to start with. First, now delta x is what? The distance traveled by this wave and getting reflected. Now you see, if this is D, then I can say this is D by 2. And this is given H. So what is this distance? This distance we can write as D by 2 whole square plus H square. Same here also. D by 2 whole square plus H square. So this wave, how much distance is traveled? This plus this. So delta x I write 2 root over D by 2 whole square means D square by 4 plus h square. This is the path traveled by this one, and this is traveling how much? Minus d. And what is question saying? Here they are in same phase, that means they are producing maximum intensity, that means constructive interference. That means what should be the path difference? N lambda. Or it should be n lambda. So I am putting it over here, n lambda equal to 2 root over d square plus 4h square by 4 minus d. This 4 we can take out and cancel this 2. N lambda is equal to root over d square plus 4h square minus d. Okay, this first equation. Second equation says when the wave is reflected from height h like this, then what will be the path difference? That also we'll write. So in that case we'll write delta x equal to 2 root over d square by 4 plus h whole square minus. I hope you can understand that. Only h is becoming h plus h. So in place of h I have written h plus h. Now what is coming over here? We are saying here no intensity is detected. That means here is a destructive interference. Minimum intensity. So in that case what will be this? This we can write as 2n plus 1 lambda by 2. Because here path differences increase. So obviously the minimum intensity that we are getting, it will be behind this or beyond this next number. If suppose this is lambda, if n is 1, then this is coming what? 3 lambda by 2. Okay, if this is lambda, then this will be 3 lambda by 2. That means slightly more. So that's equal to, again here you can take 4 common from here and cancel it. So d square plus 4 h plus h whole square minus d. This is our second equation. Now we are going to solve both these equations. Okay, these equations need to be solved. Let's see what we can do to solve them. Okay, so what we can do now? This one, this d you can bring it that side. It's n lambda plus d equal to root over d square plus 4h square. You can square that. Okay, you can square it. N lambda plus d whole square equal to d square plus 4h square. Okay, that's equation number 3. Exactly similar thing we can do over here also. That's 2n plus 1 lambda by 2 plus d equal to root over d square plus 4 h plus h whole square. Square this also, both sides. 2n plus 1 lambda by 2 plus d whole square equal to d square plus 4 h plus h whole square. Okay, now we can simplify them. Okay, first thing is we have to find n. If we get n, that's all, the work is over. Okay, so now in place of this will open here, and then this value we are going to put over here. So this value we can write d square plus 4, open it, h square plus 2h into h. That means d square plus 4h square plus 4h square plus 8h into h equal to this thing, 2n plus 1 lambda by 2 plus d whole square. Okay, now d square plus 4h square is here. What we can put? This we can put over here. We will put over here this. That is n lambda plus d whole square plus 4h square plus 8h into h. Square this also now. 2n plus 1 lambda by 2 whole square plus d square plus 2 plus 2 into 2n plus 1 lambda by 2 into d. Okay, so this 2 you can cancel over here. Alright, now we have to solve. Let's see now. Okay, this also will square it now. This is 2n plus 1 whole square into lambda square by 4 plus d square plus 2n plus 1 lambda into d equal to this over here, n square lambda square plus d plus 2n lambda d plus 4h square plus 8h into h. Okay. Now, anything we are getting, we can cancel it over. First, we'll see we can cancel it. 2n lambda d is here, 2n lambda d is here. Let's cancel that. Okay, d square is here, d square is here. Cancel it. Alright, so what is remaining? Now, this we square also. 4n square plus 1 plus 4n into lambda square by 4 plus lambda d equal to n square lambda square plus 4h square plus 8h into h. Multiply this inside. That becomes n square lambda square plus lambda square by 4, and 4 and 4 here cancelled. N lambda square plus lambda d equal to n square lambda square plus 4h square plus 8h into h. This n square lambda square gets cancelled. What we want here, we want n value. Okay, so remaining all the things we take that side. That's n lambda square equal to 4h square plus 8h into h minus lambda square by 4 minus lambda d. N equal to 4h square plus 8h into h minus lambda square by 4 minus lambda d by lambda square. Okay, so this is n value. Now this n value we have to put in the first equation, so that we are going to get relation between lambda, capital H, small h and d. Okay, I hope this is clear to you. This is our answer. Okay, so standing waves now we'll start in our next class.